Hello everybody, welcome to another episode of Google Developers Live. My name is Cole McCandless, and today we're talking about a fantastic technology inside of Chrome known as the Native Client Project. Now, this technology does something that a lot of web developers never thought possible. You see, it allows you to develop, distribute, and execute native code right in your web browser. But here's the catch. It's just as secure as JavaScript. Now, here to talk about this fantastic technology today are some of the brains of the project. I'd like to introduce our panel for today. Hello, everyone. Sitting next to me, we have Eric Kai, who's an engineering director for Chrome, as well as Molly McKinley, who's a product manager on Native Client. And also at the end is David Sear, technical lead for Knakal, and also one of the inventors of the project. Hey, listen, thank you guys for being here today on Google Developers Live.
Absolutely.
We have lights and all sorts of microphones. Hopefully it's not too big a deal. Anyhow, so Eric, tell us about the Native Client Project. What is it? What's its goals?
Well, as you said, it's about bringing native code to the web. So the question is why? Why should you care about that, right? Well, it turns out that there's a lot of native code that's been written out there, a lot of C, C++ code, and there's a lot of expertise, a lot of people who that's their bread and butter. They are developers in C and C++. There's a lot of developers also who need to use those technologies because they target a variety of different platforms. Some that require native code in order to get on them. If you're targeting for the iPhone, maybe you have a C, C++ Objective-C app. You need if you want to get that to the web, you need technology like Native Client to bring it there.
So, and that's going to help us sort of get performance. It's going to help us with security and everything else, right?
Right. Portability, security, performance.
Interesting. Now, David, you're one of the creators, right? You're there from the beginning. So, tell us a bit about Native Client. What is it doing under the hood that allows it to accomplish all these things?
Put simply, Native Client is about secure execution of native code in the web browser. So we do this by actually changing the compiler that you would use to produce the native code in such a way that it produces machine code that can only do things that are secure. The code that it generates actually sets up something that we call a sandbox, and inside the sandbox, the application can run in a way that it can't gain access to execution outside the sandbox, except through very controlled APIs, and it can't have access to other parts of the browser that might otherwise compromise security.
So it sounds like there's sort of a component on the compiler side of the technology, as well as a lot of machinery running inside of the browser, which is kind of a complex pipeline. Like, how much of this is actually visible to the user?
So from a user's perspective, when they navigate to a web application that's using a native client module, it's really a transparent process. They get all the benefit of the performance we get with the native client application, but they don't have to go through the classic plugin install gesture that we've come to know and maybe not love quite as much about the web. So it's really much more of a transparent process. They're not having to interact directly with a module. It just kind of helps them be more performant in the application itself.
Now, I think you mentioned something interesting there, the sort of plugin dialogue, right? I mean, this has sort of been the uneasy surface of the web community for about the past 20 years now. When you see that please install, you're never really sure if you're getting something awesome or something malicious, but Knakal attacks this, right? So David, how is Knakal actually ensuring this code is secure?
So we knew from the beginning that we were going to be running code that came from the web. So this can be a kind of a scary place, and the whole plugin experience sort of taught us that relying on the user to decide what was safe or what was not safe might not be the best approach to this. So the approach that we took was actually, I talked a little bit before about this, was we modify the compiler to produce these sequences that are secure. When the application, when the page actually starts up, we check through something we call the validator, part of the Chrome browser, that this set of safety rules that the compiler produces are actually followed. If the application does not follow those safety rules, the browser simply refuses to start the application. If those safety rules are started, then while the application is executing, we're still monitoring and making sure that accesses to the operating system or to other browser functionality are carefully monitored and secured. Anytime any of those, again, are violated, any of those rules for access to operating system or browser functionality, we will again terminate the application. And all of this runs in addition to the existing Chrome sandbox, which is used to secure JavaScript execution as well as native client.
So it's like there's sandboxes and sandboxes.
That's right.
It's just sandboxes all the way down.
That's right. Defense in depth.
Yeah. So now, some of these rules, I mean, most developers could hear that and say, like, my program has to adhere to rules. That's super spooky. What does it actually mean for the developer? What kind of limitations do they have in the development of their application?
So we looked at native client from the beginning, and as Eric talked about, we really wanted to bring native code in general to the web. We wanted to put as few limitations as possible on this system. So because of some of the rules that we require, if your application actually has inline assembly code, or if you're using .s files, you may have to modify those to follow the safety rules that the validator enforces. If you're using a just-in-time compiler as part of your application, you're probably going to have to modify that also to properly execute under the environment. But otherwise, we've tried very hard not to put any additional limitations on what developers can do.
So when Chrome gets sort of this package of bytecode, it has to it checks through it. What's interesting about that for me, though, is that it sounds like maybe you're not just limited to C++ to generate that code?
So we, here at Google, have built the initial tool chains. We've built a C++ tool chain and have focused most of our efforts on that. But the intent is that developers can go broad and do other platforms, other languages. Some of our developer community have already picked up on this, and in fact, we've already had ports of Lua and Python and Ruby. There are people actively working on Go and other languages out in the developer community. You can pick up some of this on Knakal ports or follow on our discussion list. But C and C++, you have full access to the Pepper APIs today. Some of these other ones, we're working on developing and adding access to the other Pepper APIs. But otherwise, language independence is a goal from the start, and we're well along that path.
And see, this is the thing that I've loved about the native client project from the start, right? Like, so I'm a bad JavaScript programmer, right? Like, I like having control over my memory access and understanding sort of the performance characteristics. And so this is something I like because I can bring this code in these other languages. But to be honest, this is a bit of a bucking a trend for the web development community. I mean, typically, since its inception, we've kind of been drilled into this one mindset of single language, single setup. But what this is really proposing is sort of opening the doors to just all sorts of new experiences and new technologies. So I mean, Eric, obviously this is big. I mean, what do you feel that the impact of this is going to be on the web over the next 5 or so years?
Well, I think your example highlighted the one of the main changes that this is going to bring, which is that there are many developers who aren't great JavaScript, web developers. They're C, C++. They use the language of their choice, and this suddenly allows them to bring their tools and their technology and their knowledge and expertise to the web. So it's going to open up the web to even more developers who, with a lot of existing software that hasn't been brought to the web. Think about this. There's a ton of native code that's been out there, being developed over the last 40, 50 years. The effort to port that to JavaScript is not trivial. These things have been vetted over time. So when you think of crypto, you think of image filters, you think of whatever. You don't want to have to reinvent that. So another interesting bit is to think about the opposite user, right? The user who is a web developer at first and knows nothing about native code. So how are they going to go take that native code and port it over to JavaScript themselves? One of the interesting things about native client is they might be able to just take an existing built module, that somebody else built, somebody that had that expertise, and integrate into their web. You want to add a Gaussian blur to your image editor? Great, grab this Knakal module that does that for you. You didn't necessarily have to know anything about C and C++ to do that. You just grab the Knakal module and integrate it with your app.
That's kind of really cool. I like the point you make about the vetted code too, right? Because that makes me think that one day I'm going to be able to just include the Mars rover navigation controller from NASA right into my webpage and use it for some crazy thing. Now, this is kind of a big vision. How have developers been responding? I mean, how has the uptake been with this?
We've actually had a huge developer response. We've had over 300 applications in the Chrome Web Store. These aren't just, your mom's web app. These are applications that are really using the full processing power of the computer, coming from really high-powered platforms, things like Tomb Raider and Tank Riders coming from Xbox 360 and PS3. We have Bastion, which comes from the Steam platform. And not just games, though both game developers really use the cutting edge of what a platform can do. We've also seen good adoption for things like CAD modeling and surgical simulations, where you're cutting open cadavers and teaching medical students, all the different entrails that, lots of crazy stuff going on. But these are high-powered applications that are really pushing forward what we can do, which is wonderful. Things like image and video editing that really are taking advantage of everything Native Client can offer.
Now, a couple of weeks ago, I know that it was announced on the Chromium blog post, sort of a new, I guess, a flavor, if that's the right version of it, called Portable Native Client, or Knakal?
Pinnacle.
Pinnacle. Tell me a little bit more about Pinnacle.
So Pinnacle is another flavor, as you say, of the Native Client project. And what this does is introduces an intermediate representation between the language, the C and C++, the developer codes, and how a user runs that natively on their computer. And through this intermediate representation, we can make sure that in the future, as new hardware is developed, we can continue to target all the different users' computers. With the original Native Client project, you had to compile once for every type of user computer you wanted to support. With Portable Native Client, we don't have that problem. We translate on the fly given the user's hardware type. This means that we're portable, as we say in the title. We're portable across all of these different architectures. Previously, because Native Client was this architecture-specific binary, we had to kind of gate how we let that out. We needed to make sure that we were future compatible in the web. And so therefore we put Native Client modules in the Chrome Web Store. With Portable Native Client, don't have that problem, you don't have that gate.
So I like what you say there about sort of future proofing. I mean, everyone, really, let's be clear here, like the buzz in the tech world right now is less on software and more on hardware, right? We got new devices coming out in a bunch of different areas. I mean, Google Glass, tons of different Android things. I'm personally looking forward to Google Shoe, which is nice because that means Pinnacle will support whatever silicone-based, pump-ups. I remember the Nike pump-ups. Those to me were the pinnacle of shoe. Like when I can control, like that was it. Anyhow, so it sounds like there's kind of a big move here, right? From the static architecture-specific compilation to this sort of translation that then gets turned into whatever the underlying architecture is. So this sounds like a pretty big shoveling of code. Like, David, how did that go with the engineers? Was this like a monumental effort, or was it pretty easy?
It's been a pretty big effort. So we started with the GCC toolchain targeting, as Molly said, basically one executable platform at a time. So x86, 32, or 64 or ARM. And with Pinnacle, we wanted that to be one platform-independent binary, or what we're calling a PEXI. So we started with a tool called Clang from the LLVM tool suite, and it produces bitcode. This bitcode we made some modifications to make it more suitable to the web, to being hosted over time in a website. And then once we had done that, we had to look at translators for all these platforms in addition. The translators themselves to each one of the platforms are based again on the LLVM toolchain, on the backend compiler for that. And so we had to build one of those for all the supported platforms, and we've worked with some people externally to add some more supported platforms over time as well. So it's been a lot of work in doing this, and also the security standard that we set with Knakal was an important part of this. So securing both the translation process and the executable code is done through Native Client as it was before. So it's been a long development effort, and the engineers, I think, are very relieved. We're all really happy to be at this point now, and we think really cool things are to come.
And see, I remember actually reading some of the original publications you guys did on this, and even back then it was really weird to me, like, wait, this sounds like a huge amount of work, but it sounds like the team has done fantastic with it, and with the uptake that has already been there. I mean, it's amazing. So now that you're moved on to Pinnacle, or well, not moved on to, but I mean, now that this thing is rolled out, I mean, what's different for the user, right? Like if someone's developing a Knakal app versus a Pinnacle app, how does the user experience the two differently?
So for the user, when they're navigating to a page that contains a Pinnacle app, they still have that same transparent experience using all of the feature set, the performance that we enable through Native Client. But now Pinnacle applications can be embedded in a web page. You navigate to a tab, you use the benefits of Pinnacle, you get tired of it, you're busy, you want to go and edit your video in a different tab, you navigate away. And so now you have this kind of seamless interaction where you're getting pages that are powered by Portable Native Client, but they don't have to go through the same Chrome Web Store install process that you had with the native client executables. So it's similar very much from the user perspective, but just more free-flowing in the web at large.
That's interesting. And so, like, some of the examples you gave, though, they talk about basically access to native resources, right? You've got high-powered compute, you've got access to, TCP, UDP, and stuff like that. So I guess this is kind of the question that the community brings up a lot, is, so if I can just browse to a random web page and they have access to some of these APIs, Eric, is this something I should be worried about? Is someone going to turn on my webcam when I don't know?
Absolutely not. As Dave pointed out before, the security model for native client basically is exactly the same as JavaScript. So native client really can't do any more than what we allow what normal web pages to do before. The main thing is just the code that the developer uses to write that, and the performance that they're able to get as a result of it. Native client is sandboxed from the underlying operating system. It can't directly access things, so it only accesses these capabilities through APIs like Pepper that we've developed, which basically mirror what's in the web platform. In fact, because of that, we've been able to take the Pepper APIs, and create JavaScript wrappers for them called Pepper.js, and expose that to Emscripten, so people can even target Pepper as a cross-browser solution for their native applications.
Now, see, that's really interesting. So you're telling me that, because one of the big vocal points about the native client technology is sort of it's Chrome only, but you're telling me that targeting the Pepper APIs and then this Pepper.js project sort of allows you to take your application that you've targeted for native client and actually get it into other browsers through the JavaScript route.
That's right. And it won't be quite as performant as if you targeted native client. You might not be able to take advantage of things like threading, things that aren't in JavaScript. But yes, you'll be able to get the portability of cross-browser.
And that's really cool, right? Like it's a complex web, so I'm glad that this is sort of added to the project. So talk about this a little bit more. When we talk about accessing native resources, one of the big ways that developers have been approaching this problem for a while has been with NPAPI-based plugins. And recently it was announced that we're going to depreciate those. So can you talk a little bit more about that decision and whether, is Knakal a viable solution for these developers?
Absolutely. So as I mentioned before, Knakal is sandboxed from the underlying operating system. NPAPI is sort of the opposite. NPAPI was designed, it was intentionally designed to give web developers access to the underlying operating system. Now what that means, unfortunately, is it means there's no security guarantees of it. And so that means that if the plugin has any security vulnerabilities, any web page can take advantage of those, can exploit those. And as a result, it turns out that plugins have historically been the #1 source of web browser vulnerabilities. By deprecating NPAPI in Chrome, we're getting rid of that one last big security hole that has been sitting there.
And so that was always the scary part, right?
Well, it was always the goal, and it's why we developed Pepper. It's why we have built-in Flash using Pepper and a PDF reader using Pepper. Those are built into Chrome so that we sandbox those first, and now this is just closing down the others. And so if you're an NPAPI developer today, Knakal can be used as a replacement as long as you're not trying to access unsandboxed resources in the operating system. So if what you're doing is using this as a way to bring native code to the web, then Knakal is what you want. If what you wanted was direct unsandboxed access to the operating system, unfortunately, we're closing that up now.
Yeah. Well, I think this is the right thing, right? The web should be about getting information and about trading ideas and finding what you need. You shouldn't have to walk into that area being afraid to click on a link. That's not the web you want. You want free information in exchange. So listen, this is fantastic stuff, right? We're talking about big vision stuff here, changing security models in the web and the way languages and the way developers look at things. So Molly, give us the vision. What's next for the native client project? What's the 6-month, 8-month ramp? What can developers be excited about?
Absolutely cool. So we have some cool new stuff right out the door. We want to get things like C++ exception handling in there. It's something that, talking to our developer community, was something that they loved about the native client project, and they want in portable native client as well. And so we're working on, right out the gate, adding that as quickly as we can. A big thing that we're thinking about as we move forward is performance. We want the load time when you load a native client and portable native client application in a page, that translation time to be as small as we can get it. And so we're working on decreasing that as we speak. Another thing is the size of a portable native client module. We want to decrease that, optimize every little last megabyte that we can, and make sure that that's as small as we can get it. And finally, moving forward, one of the big things we want to work on is the debugging experience, making sure that we're really receptive to our developers, hear their pain points, and try and optimize for their development suite and how they go about making a native client application. So that's as smooth and hiccup-free as we can get.
That's good. That's good. So it sounds like lots of good things have already been done. Amazing technology, really trying to change the face of the web. And so we've got a couple questions that I want to get to here in a minute. But before I give the masses their shot at you guys, I got a question because this is really one of the things I want. When is Knakal coming to mobile? That seems like the perfect melding of these two worlds. Can you talk about that, anybody?
So we've been focused on desktop, so it's a little early to talk about anything there, but stay tuned.
Okay, I like that. I'll take that. All right, now the masses can get their shot at you guys. All right, so let's take a look at our questions that we opened up earlier in the week. So first one, are there any plans to have portable native client communicate to the browser via JavaScript APIs, like ASM.js does, as opposed to the Pepper plugin APIs?
All right, so I can jump on this at first, and you guys can hop in with your pieces. We don't currently have any plans to have a native client application talks directly to JavaScript. I think Eric talked a little bit about Pepper.js earlier on and how that ties up with the JavaScript libraries. But for a native client application, when you have native code that wants to communicate, we really do want to route it through a secure API that we can make sure it's not going to do anything malicious, and we can contain that access. And so really what the Pepper APIs do is connect up with the same sort of back-end fundamentals of the JavaScript APIs. And so as we add functionality to the Pepper APIs, that sort of coverage of the APIs available is going to increase. So we don't have any plans of letting JavaScript, direct JavaScript API access.
To build on that just a little bit, one of the design goals of the Pepper APIs was actually to provide a securable and smooth interacting with the browser experience for plugins. Actually, one of the things that plugins, Eric didn't talk about this with NPAPI, et cetera. One of the constant complaints was, gee, when the plugin does something that ties up the JavaScript and makes for an awkward experience in the browser. That, when the foreground of the JavaScript is not responding, you get that nasty little pop-up that says JavaScript become unresponsive or whatever. So PAPI was designed with that sort of jank-free experience in mind, and also having a separate process that actually you're running the native code in is yet another layer of securing the application. We really like the fact that it's a separate process, and that if that process crashes, it doesn't take down the renderer, it doesn't cause some of the awkward experiences that people have come to see with plugins.
Now, answer this really quick as sort of a follow-up to that. I mean, so the question was like, ASM.js interacting with the browser. I mean, that's standard JavaScript, right? I mean, it's not really accessing anything that JavaScript's not exposing. It's not doing magic, right? Or am I
No, that's right. It's just a subset of JavaScript.
Okay, and currently Knakal actually can communicate back to JavaScript through post message. So I mean, so there is some communication there, right?
That's right.
Interesting. Okay. Good. So number 2, are there any performance considerations that developers should take into account when using Pinnacle versus the old static compiled toolchains?
Okay, there are a couple of performance considerations. Some of them are sort of longer term, and a couple of them we will be phasing out as concerns over the next few releases. So first of all, portable native client is intended to be portable. So if you've used assembly code, if you've got .s files in your build, or you've got inline assembly code, these are things that are sort of inherently non-portable. So if you have hand-coded assembly code, you're going to need to find ways to do that otherwise, or not pick portable native client as the approach. A second and something we're working to phase out is, for instance, some of the things people were doing with the inline assembly or with .s files was access to SIMD instructions. Vector instructions to do all kinds of things appear in every successive generation of most hardware vendors' products. We're going to be adding SIMD instruction support to the existing set of performance features of portable native client over time, but at this point, if you're expecting to be able to use SIMD instructions, you'll probably need to wait.
And so I got to tell you, I'm glad that SIMD is coming, because that's really the thing that took my hair away back in the games industry, was trying to like optimize the right SIMD instructions for the architecture and get the right thing like that. So great, it's good that my blood pressure can go back up again. My doctor's going to really appreciate that. Next question. So how much effort would it take to port an app built using native client to portable native client?
I think the good news there is, if you've already done the work to port to NPAPI API, unless you're using just-in-time compilation or inline assembly, the port should be very simple. Should be almost as simple as just switching the compiler flag for your makefiles or whatever build environment you use. If you're using some of those features, then you will have to do some work to get around that.
And so most of the Knakal tool chain, does it insulate you from this? Is it two separate tool chains, or like how would a developer go through that?
Well, in the SDK, we have the Knakal SDK is the set of tools you download to build native client applications, and the SDK does its best to insulate you from this. So it's just a config file change when you build to target Pinnacle versus to target Knakal.
Good. So it's pretty seamless, right? I mean, there's obviously devil's in the details, but that's for programmers to deal with, right? Yeah. So is there a public timeline for allowing native client across all web pages, not just apps distributed through the Chrome Web Store? I think we've kind of tackled this pretty well, right?
That is portable native client.
Yeah,
it's shipping now.
That's what. Go play with it immediately at this moment, right? This is that's good. I love seeing a question that's like, no, yeah, we're good with there. No curveballs there. Here's another one. When will vector data types and SIMD be supported in Pinnacle?
We're actively working on that at the moment. In fact, we'll publish some data here fairly shortly of what we're proposing as the first set of things that will be supported. Don't have the dates exactly set yet, but we're working on it as we speak.
Yeah, add the lower Colt's blood pressure intrinsic. I'd appreciate that. Final question that we're going to have for today, because I think we're running out of time. Will the TCP socket API be available to portable native client applications being served via a website?
So no, and there's a good reason for that. As we mentioned before, the whole point of this is to have the same capabilities as web pages. So, if we come up with a security model for the web that would allow us to have TCP exposed to JavaScript, then we would expose it to portable native client. But since we don't, since the security model of the web doesn't allow that today, we're not exposing any additional features like that to portable native client.
Now, do they have access to some of these features? Because I've read the documentation in standard native client, right, distributed through the Chrome Web Store.
Well, if you use packaged apps, you can use portable native client or native client, and then yes, you can use the packaged apps APIs to do networking there. But since the questioner asked about on a website as opposed to in a website, no. In a packaged app, yes.
Awesome. Well, hey, listen, thank you guys so much for taking the time to talk about portable native client today. It's an exciting product. I'm really glad to have been associated for so long. So, hey, if you're watching the stream and you want to know more about portable native client, make sure you visit gonakal.com. That's going to be the place where you get all of your information, stay up to date with announcements, news, demos, everything. Hit that. My name is Colt McCandless. Thank you for staying tuned for another great episode of Google Developers Live. Thanks.